Hi everyone, my name is Amitesh, and in this video we're going to master the derivatives of arcsin x, arccos x, and arctan x. So these come up a lot in calculus, these inverse trig functions. They come up a lot in calculus, and I want to just help you really understand why the derivatives of these functions are what they are. And what's so cool is that unlike the trig functions, the derivatives of these functions look like just x. They don't involve any trig functions for each of them. So that's super cool, and this will also be practiced with implicit differentiation. Okay, so a lot of stuff's going to be all in one video just for you to help you master calculus. And this is as I've taught multiple times at Princeton University. I've taught the derivatives of these inverse trigonometric functions and how to think about them, and I hope this video is going to benefit you. So let's just dive right into it. So the first step is what is going to be the process we're going to follow. Let's do it step by step. Let's start off with arcsin x. Okay, so this is the inverse of sine. It is not 1 over sine x. Okay, it's the inverse of sine. Okay, so it's what you have to plug into sine to get the value. That's arcsine of something. Okay, so arcsine of 1 is pi over 2 because sine of pi over 2 is 1, for example. But we don't have to really think about that too much. Let's just write out the function. So y equals to arcsine x. So the first step is we don't like arcsine. I mean, we don't really understand it, but we understand sine, right? So then we understand arcsine. So if we have y equals arcsine x, and a thing we can do is we can take sine on both sides. So as I said, if y is arcsine x, sine of arcsine x is x, because arcsine and sine are inverse functions. So we're just going to get that sine of y is going to equal to x. But if sine of y is equal to x, now we've got something we like. So we sort of look familiar to us. We can now differentiate both sides of the equation. And this is where implicit differentiation comes in. So sine of y, how do we differentiate sine of y? So remember that y was a function of x, right? So when you differentiate something that is sine of something, not sine x, right? That derivative is cosine x. But sine of something, you have to use the chain rule. So you differentiate the sine, you differentiate the outside first, keep the inside fixed, then you differentiate the inside. Okay, so whatever that is, we don't know. Okay, but that's needed because it's a chain rule. It's not sine x. Okay, you're differentiating with respect to x. It's sine of something. So you differentiate, if it was sine of x squared, you'd say cosine x squared times 2x. You differentiate the x squared. It's the same business here. So you get cosine y times dy dx. Okay, whatever that is equal to the derivative of x with respect to x, which is just 1. So we get that. And now this is super cool because we're just going to solve for dy dx. Okay, this is how implicit differentiation generally works. It's an easier example of implicit differentiation. It's when you have inverse functions. So dy dx is going to be 1 over cosine of y. And now we just plug in. Okay, so you could leave it like that, but you want to plug in now what y is. Y is arcsine x. So it's going to equal to 1 over cosine of arcsine x. Okay, now this we don't like. Okay, so it's possible that the people who are studying calculus first of all, they found out this formula and then they were kind of like, okay, fine. But maybe someone kind of thought a little bit more and saw this is actually super cool. Okay, so this is one of the most exciting parts of this video is we can actually simplify this really nicely. So what is cosine of arcsine x? Well, we know sine of arcsine x is x, but cosine of arcsine x, we know how to express cosine in terms of sine. Super cool trick. Whenever you think it could be useful to express cosine in terms of sine, think the cosine squared plus sine squared is one formula. Okay, so just to recall that formula, we know that sine squared x plus cosine squared x is equal to 1. So therefore, you can solve for cosine x. Cosine squared x is equal to 1 minus sine squared x. This is actually the Pythagorean theorem, by the way. Okay, it's nothing fancy, but therefore cosine x is equal to the square root of 1 minus sine squared x. And check out my video on the Pythagorean theorem. I explain it really clearly, a proof of it. If you haven't seen that before, I really love the proof. So check it out. It's a beautiful geometric proof, very creative. So cosine x is going to be root 1 minus sine squared x. So what we can now do is use this trick. Okay, use this to express cosine of arcsine x. We know sine of arcsine x. Okay, so therefore we know that cosine of arcsine x is going to equal to the square root of 1 minus sine squared of arcsine x. Okay, and remember that sine squared of something is sine of that thing squared. Sine of arcsine x is just x, right? So we get 1 minus x squared, the square root of that. So this is the square root of 1 minus x squared. Super cool. This is so nice. Now we can just erase this. So I'm just going to actually do that here. I'm just going to erase this here and just say that the derivative of arcsine x is going to be the square root of 1 minus x squared. Okay, so that's going to be the derivative of arcsine x. Now this formula is only valid, you can't divide by 0, you can't take the square root of a negative number for real numbers, so this formula is only valid when the absolute value of x is less than or equal to 1. Okay, actually the absolute value of x is less than 1. Okay, when x is 1 or minus 1, you're dividing by 0. So that's also the domain of arcsine. You know, you can't take the inverse of sine unless your number is between minus 1 and 1. And at minus 1 and 1, it turns out not to be differentiable. But you can't take the inverse otherwise. So that's the formula for the derivative of arcsine x. Super cool. Now what I want you to do is to try, before watching on, and I encourage you to watch on because I will leave some cool tricks, you know, for remembering these formulas as well. And also walking through the steps to really master implicit differentiation and master trig identities in the process too. Because we're using trig identities in simple ways, but I encourage you to try to differentiate these functions yourself, okay? And at the end of the video, I'll give you a screenshot thing. You can just screenshot and remember the derivatives. So now let's get to arc cosine x, okay? So arc cosine x, it's going to be y equals to arc cosine x. So what is dy dx going to be? Okay, so we're going to now do the same trick. We don't like arc cosine, but we like cosine. So we're going to take cosine on both sides. Cosine of arc cosine is going to give back the input, so that's x. So cosine of arc cosine x is just x, so cosine y is just going to equal to x. Now we can differentiate both sides of the equation, so pretty cool. So we can use, again, implicit differentiation. The derivative of cos is negative sine, okay? So it's going to be negative sine of y, right? So I like to sort of remember implicit differentiation. You differentiate the outside, which is the cos, so you get minus sine. Keep the inside the same, and then multiply by the derivative of the inside, which is a function of x. If it was just x, we don't have to do anything. But it's a function of x, so we have to do something. And this is something that trips people up sometimes with implicit differentiation, so I'm just emphasizing this, you know, so that everyone can really master and understand this process. Now we get minus sine y is dy dx is 1. So therefore we get the dy dx. Solving for dy dx, as you do in implicit differentiation, you're going to get minus 1 over sine y. And don't worry if you don't know what implicit differentiation is. Actually, I'm sort of teaching you the process. So when you see it, you know, you'll have a leg up, okay? So that's also part of the point of this video. So you get minus 1 over sine y, and now we just plug in, okay? So this is going to be minus 1 over sine of arc cosine of y. So arc cosine of x, my apologies. So as you can expect, you know, you already know the punchline is there's going to be some way of simplifying this. So again, you know, try to do it yourself. If you haven't done it, try to do it yourself. Try to see what you get. So let's try to do this directly. So I'm going to explain this sine of arc cosine y. So I'm just going to skip right to the formula. So using, you know, the fact that sine squared plus cosine squared is 1, you know that sine x is going to be root of 1 minus cosine squared x. And so we know cosine of arc cosine x. Okay, so I'm trying to write sine in terms of arc cosine, a sine in terms of cosine, so I can figure that out. So sine x is square root 1 minus cosine squared x. So therefore we know that sine of arc cosine of x is going to equal to square root of 1 minus arc cosine cosine of arc cosine of x. So cosine squared of arc cosine of x, and that's going to equal to square root of 1 minus x squared. Okay, so that's going to be a square root of 1 minus x squared on the bottom. So we're going to now, I'm going to ask you a cool question, okay? So this is a really cool question that I really love. I'm going to challenge you. But before I do that, I'm just going to write this out. So we put a minus 1 on the top, and we have on the bottom square root of 1 minus x squared. Okay, so it's really cool that these derivatives do not involve, you know, that's quite remarkable. Like the derivatives do not involve the trig functions. You know, they're just involving x. But this is so similar to the derivative of arcsine x, right? The derivative of arcsine x was 1 over root 1 minus x squared. Now I have a question for you. How come they're so similar? If two functions have the same derivative, they differ by a constant. So if the derivative of arcsine is negative the derivative of arccos, that means that arcsine plus arccos has to be a constant. Why is that? Drop me a comment down below. I'd love to see your explanation. It's a cool exercise. You know, why is that a constant? Okay, but let's now finalize with the tan, and this is going to use a different trig identity. Okay, it's not going to be the same process here. So let's kind of get into that. So the trig identity we're going to use for arctan is going to be a little bit different. So let me just erase this on the board. And I want you to try to work it out yourself. You know, always encourage, if you just want entertainment, just watching, that's perfectly fine. You know, you can definitely learn. If you think about how babies learn stuff, right? They just kind of, they hear a lot of stuff and they don't even speak anything, but then one day they start speaking and rapidly they've absorbed everything. You know, in the same way you can watch and you can absorb, but it's still important at some point just to do the speaking part. But you're still learning, okay? So let's go to arctan x. So what is going to be the derivative of arctan x? So this is 3. So y is equal to arctan x. And here I really like, this is going to be another trig identity, so let's dive into it. So y is equal to arctan x. So again, same deal, you know, we don't like arctan, but we like tan. So what we're going to do is we're going to put the tan on both sides. So we're going to get tan y is going to equal to tan of arctan x, which is just x. So now we're going to differentiate both sides of the equation with respect to x. So the derivative of tan is secant squared, okay? This is a good one to remember. You know, don't worry about the secant, cosecant, cot. But derivative of tan is really important. Just gives you a leg up, you know, when you need it in problem solving. But the derivative of tan is going to be, so you differentiate the outside, it's going to be secant squared of the inside times the derivative of the inside, which is dy dx. So it's going to be just dy dx. Again, y is a function of x. It's something we don't know really. I mean, it's arctan, but we don't know dy dx. And then we know the derivative of x is just 1. So therefore we get that. So dy dx is going to equal to 1 over secant squared y, right? 1 over secant squared y. And now we know it's 1 over secant squared y. Well, if it's 1 over secant squared y, then that's just going to equal to, well, secant squared is 1 over cosine squared y. Okay, so this is just going to equal to cosine squared y. So it's going to equal to cosine squared y. So now we've got 1 over secant squared y is equal to cosine squared y. We know that's dy dx. Now we want to figure out how to write that out nicely. So first let me just write that out as cosine squared of, well, y is arctan x. So it's cosine squared of arctan x. Okay, so what is cosine squared of arctan x? So here, actually I'm going to now use an identity. Okay, so I've kind of done these 2 steps, but I'm going to use an identity with secant and tan. Okay, and this is the identity. So let's kind of write it down here. The identity is going to be the following. It's identity that 1 plus tan squared x is going to equal to secant squared x. Okay, so that's the identity. And this is a famous trig identity. I encourage you to try to work it out and drop me a comment down below. You basically have to use sine squared x by cosine squared x plus cosine squared x. It's actually so easy. I'm just going to do it here. So it's going to be sine squared x by sine squared x plus sine squared x by cosine squared x. That's going to be that, and that's going to equal to just sine squared x. Oh, sorry, it's going to be, my apologies. It's going to be cosine squared x there. So it's going to be cosine squared x by cosine squared x. And that's going to equal to, using the fact sine squared plus cosine squared is 1, that's just going to equal to 1 over cosine squared x, which is just going to equal to secant squared x. Okay? So we know that 1 plus tan squared x is secant squared x. So therefore we know that secant squared of arctan x, right? So therefore, secant squared of arctan x is going to equal to 1 plus tan squared of arctan x, which is going to equal to 1 plus, well, tan squared arctan x is just going to be 1 plus, tan squared arctan x is x squared. Okay, tan of arctan x is x, tan squared arctan x is x squared, so it's just going to be 1 plus x squared. So actually we don't need this thing here, but we could have just tried, we could have written it that way maybe, but you know, it's just easy to just directly write this out. This is going to be 1 over 1 plus x squared. Okay, so that's going to be the answer there. 1 over 1 plus x squared dy dx, and that's the derivative of arctan x, which is a really nice, you know, no square roots involved. Arctan is always differentiable because the range of tan is going to be everything. Tan goes from minus infinity to infinity. And if you remember the graph of tan, so arctan, its domain is everything and its derivative is 1 over 1 plus x squared. So now, you know, let's just do this quick like cheat sheet. You know, I want you to be able to screenshot this and remember this, and you know, you don't have to remember too much. You know, we're lucky that I wouldn't even say that remembering the derivative of arcsin is super important. It does come up, but I feel like arctan comes up a lot more. You know, it's a nicer function and it's a good function to understand. But I'm just going to say this, okay, so if y derivative of arcsin x dx, I want to kind of give you a cheat sheet. So to remember, this is going to be equal to 1 over root 1 minus x squared for absolute value x less than 1. And if you've watched this far, please leave a like and subscribe and share. You know, everyone asks for this, but I'm really trying to help as many people as possible and change lives through math education. And I want everyone to have the opportunity to benefit from and love math at all levels. You know, so my channel is all levels of math. It's not just, you know, it's an emphasis on high school and college math, but math at all levels so that Everyone can love and enjoy math. And by liking, subscribing, and sharing, really help my goal by disseminating the videos. YouTube is free. Watching this is totally free. But by liking and subscribing, it's also free, but it disseminates my videos and helps me change lives. So thank you so much for watching so far. And I'm going to now end the video just with these derivatives. So this is going to be minus 1 over root 1 minus x squared. I'm going to give you some tips for remembering them. Okay, so watch till the end. But here we've got that. And the derivative of arctan x is going to be equal to, so let me kind of just write that here. The derivative of arctan x with respect to x is going to equal to 1 over 1 plus x squared, and this is true for all x. Okay, so those are going to be the derivatives. Now, my quick tips for remembering these is, I would just say that remember the derivative of arcsin x. Okay, the derivative of arcsin x is 1 over root 1 minus x squared. You just got to remember the square root. Remember that whatever is inside the expression here can only be defined when the absolute value of x is less than 1. That's what you have to remember, because the domain of arcsin is all numbers from minus 1 to 1. Okay, so because the range of sine is all numbers from minus 1 to 1. So you kind of can remember the 1 minus x squared, and you remember the square root because you can't take the square root of a negative number. So you want this thing to be something that is always positive on the domain, and it's not defined at the endpoints. Okay, so at x equals 1 or minus 1 is not defined. So that combination of things tells you've got a 1 minus x squared, and you're taking a square root because you don't want it to be defined when x is greater than 1 or less than minus 1. And similarly, once you've got arcsin down, arccos is the negative. The derivative is the negative of that. That's, it's not the same thing. So otherwise, they would be the same function almost up to a constant, but its derivative is negative of that, so just got to remember that. And then the arctan, it's 1 over 1 plus x squared. I just like to remember there's no square roots involved. Arctan is defined everywhere. It's a really nice function. The graph looks something like this. So I kind of show you as a bonus. It looks something like this. Kind of looks like this. It has horizontal asymptotes at infinity and minus infinity, if you're familiar with that. But that's going to be the graph. So the derivative is 1 over 1 plus x squared. And you can kind of sort of remember the 1 plus x squared. It's a nice little function. It's defined everywhere. If it was just x squared, it wouldn't be. And then you can sort of get down the derivative of arctan. So I hope you loved that video. Please leave a comment down below answering the question as to why the derivatives are so similar, which means that arcsin plus arccos has to be a constant. So why is that? What is that constant? I'd love to see your comments down below, and I'm super excited to see you in the next video. Wish you all the best. Thanks so much for watching. I hope I was able to support you with this content, and I hope you have a wonderful day, evening, or night wherever you are. Super productive, super happy, and I'm super excited to see you in the next video. Check out my channel. I've got lots of cool content, all different levels of math. Every video is designed to be as accessible as possible, assuming only the minimum amount of information that's needed. Here I basically just assumed the chain rule, and I basically assumed what trig functions are. I didn't even sort of use much of an understanding of arcsin or arccos to differentiate it. So every video is designed to be accessible. Check them out. Even if you don't understand everything, you can get something out of it, and that's the goal of my channel, and you can really elevate yourself to higher levels of math. And I'm wishing you all the best, as I said already, and I'm super excited to see you in the next video.